Hello everyone, welcome to this video. In this video, we are going to cover the chapter quadrilaterals. And before that, if you have completed the chapter triangle, then it's very easy for you to understand all the topics in this chapter because mostly all the topics in this chapter are directly linked with the triangle. So before covering this video, let's revise the triangle chapter. Okay. So I am telling you the topics which we have to cover in this thing. So first of all, when we are clear actually what the quadrilaterals are and basic terminologies and all, then we will define an angle sum property. Okay, and after that there are some types of quadrilaterals and associated properties of them. Now the last topic of this video or of this chapter will be midpoint theorem. Now, first of all, we should know actually what the quadrilateral is. Okay, so quadrilateral is a polygon with four sides, four vertices, and four angles. Okay, so which means any figure consisting of four lines like that. Okay, is a polygon. Polygon means a closed figure consisting of straight lines. That should be clear to you. With four sides, yes, this one, the first side, second, third, and fourth. So these are the four sides, four vertices. We can name them A, this one, this vertex is A, and we can name this one as B, C, and then D. So these are the four vertices and four angles also. So it's also clear this one. Okay, so it's all actually what the quadrilateral is. Now we have some parts in the quadrilateral which we have already defined. Like first of all, its side. They are like sides of this quadrilateral are, we can say it is AB, BC, CD, and AD. So there are four sides in this quadrilateral, or in every quadrilateral, we have four sides. Now vertices, the four corner points. Okay, it's written there. Vertices are the four corner points. So they are A, B, C, and D. So we can write vertices are A, B, C, and D. Now this thing is diagonal. So diagonal are the line segment joining opposite vertices. Okay. So in this polygon of four side, which is known as quadrilateral ABCD, if we have any straight line, like if we start from D, suppose it goes up to B, then this straight line will join the vertices of opposite side. Like for D, opposite side is B. Okay, and with A, the opposite side is C. So the line segments BD is equal to BD, and we can draw one more. Okay, let me use different colors so it will be more clear to you. BD and AC. Okay, the red color one are the diagonals. Now there are some types of quadrilaterals which we have to do in this chapter. So first of all, it's our trapezium. So its trapezium is a quadrilateral with one pair of parallel lines, which means any quadrilateral, suppose like that. If any two sides are parallel, then we can say it's trapezium. Okay, and generally trapezium looks like that. Okay, this is our trapezium, and if we can name it, it will be A, B, C, and D. And side AB is parallel to DC. We can say AB is parallel to DC. So it's solved for trapezium. Now the next one is parallelogram. Okay. So in the word itself, parallelogram, the word there is parallel. So in parallelogram, opposite sides are parallel and equal. Okay. Suppose if I make, okay, suppose this is one of the quadrilateral, and in this we have vertices A, B, C and D such that AB is parallel to CD and both are equal. Okay. And AD is parallel to BC and both are equal. So in such a case, we can say it's a parallelogram. Okay. In this, we have AB is parallel to BC and both are equal also. Also, we have AD is parallel to BC, and one more thing, AB is equal to DC. Also, AD is equal to BC. Actually, what it is? It's the opposite sides like AB and CD. They are parallel and equal. AD and BC, they are parallel and equal. So it's for parallelogram. Now the C, this one rectangle, and I hope all of you already know about this like previously. So rectangle we can define like that, a parallelogram with all angles 90 degree. Okay, suppose in this parallelogram, if I make like that, then opposite sides are equal. Okay, they are parallel also, and each angle there is equal to 90 degree. So if all these properties satisfy, then we can say the given figure A, B, C, D is the rectangle. Okay. So rectangle have all properties of the parallelogram, but additional one is that each angle, which one angle A is equal to angle B is equal to angle C is equal to angle D, which is 90 degree. Okay. Now the next one is rhombus. So we can define rhombus like that, a parallelogram with all sides equal, which means first of all, let me make a parallelogram. Suppose it's parallelogram. Okay. But if we shrink this one and it look like that, in which all sides are equal. Okay. Which means this one, this one, this one, and this one. If all sides are equal, then we can say it's a rhombus. Okay. But the condition of parallelogram should satisfy that opposite sides should be equal. Okay. It's necessary. Opposite sides are parallel. Equal, all are equal. Okay. So we can say AB is equal to BC is equal to CD is equal to DA. It's for rhombus. Okay, and in rhombus we have no such criteria of angle like rectangle. Okay, the only condition is that opposite sides should be parallel, which means AB parallel to CD and BC parallel to DA. Only this condition and the equality holds. Then we can say the figure is rhombus. Now the next one, which is square. So square is the quadrilateral with all side equal and all angles 90 degree. Or we can say square is a rhombus with each angle is equal to 90 degree. Okay. So if we can draw like that. Okay, suppose in this figure or quadrilateral A, B, C, D, we have AB is equal to BC is equal to CD is equal to DA, and each angle are 90 degree, which means angle A is equal to angle B is equal to angle C is equal to angle D, and all are 90 degree. Okay, so we can say this one is square. Now the last one, which is kite, and it's like totally new for some people, but everyone is like familiar with the kite, real one, which we can fly. Okay, so it also look like that. We can draw like this. So in the kite is the condition that two pairs of adjacent sides are equal, which means suppose if this is the quadrilateral ABCD, then we should have AB is equal to AD. Okay, this thing. And one pair of opposite angles are equal, which means this angle is equal to this. And like look carefully, it's written that two pair of adjacent sides are equal. So BC is equal to CD also. This one equality for the sides. Now for angle B is equal to angle B. Okay, so that's all for actually what are the quadrilaterals and some of its type. Now we are ready to define the angle sum property. Okay, so angle sum property states that the sum of all interior angles of a quadrilateral is 360 degree. Okay, suppose we have any quadrilateral. This one is A, B, C, and D. And this one is angle A, this one is B, this one is D, and C. So angle sum property states that angle A plus angle B plus angle C plus angle D is equal to 360 degree. Okay, it's the property for the any quadrilateral. It may be rectangle, square, rhombus, parallelogram. Okay, it depends, but the condition is same for each one. So now we are able to do some questions. So it's our question number 1. It's written there that the angles of quadrilateral are in ratio. Okay, let me make it clear. They are in 2 ratio 3 ratio 4 ratio 5. We have to find the angles. Okay, so whenever ratio is given, we can simply let angles of quadrilateral be like we have 2 ratio 3 ratio 4 ratio 5, so we can simply take 2x, 3x, 4x, and 5x. Okay, but we know according to angle sum property, sum of all the interior angles of the quadrilateral should be 360. So 2x plus 3x plus 4x and then 5x, it should be 360. Now 3 2s are 5, 5 5 10, then 14. So 14x is equal to 360, or we can write x is equal to 360 divided by 14, and if we solve it's to 7 1 21680. So we can say the value of x is equal to 180 by 7. Okay, now this is the value for x. Now what will be our angle? So one of the our angles is 2x, so it will be 2 multiply 180 by 7, or if we can solve it will be 360 by 7. Now for other angles you can calculate using 3x is equal to 3 multiply 180 by 7, and which will be is equal to 540 by 7. Okay, in similar way you can calculate the 4x and 5x. Okay, that's all for this question. So generally in such type of questions where we have to use the angle sum property, we can directly add the given angles and we will find our answer. Now this question number 2. So in a quadrilateral, one angle is double the second, the third is 3 times the second, and the fourth angle is 40. So what is given? Okay, first of all, we will let one angle be of x. Okay, then if we know any angle is x, then it's given that one angle is double the second and third is 3 times the second. Okay, so we can have that any other angle will be it's double, so it's 2 times of x, and third is 3 times the second, so another angle will be 3x, and it's given in the question that fourth angle is 40 degree. So given four angles will be, they are x, 2x, 3x and 40. And according to angle sum property which we have done now, so we can directly write x plus 2x plus 3x plus 40 is equal to 360 degree. Now 3 2s are 5 and 6x is equal to 320. Okay, and we can find x is equal to 320 by 6, and it will be equal to like 160 by 3. Okay, that's our value of x. So our angles are x, 2x and 3x. So in the place of x, we can directly write 160 by 3. In 2x, 2 multiplied 160 by 3. And in place of 3x, 3 multiplied 160 by 3. And they will be 160 by 3 and 320 by 3 and 160. Okay, so these are the three angles which we have to find. And fourth one is already known to us, which is 40 degree. So it's the way in which we can solve the questions in which we have to find the angles using the angle sum property. Okay, so that's all for this video. So keep practicing and do like similar questions like that. It will make your concepts more clear. Still, if you got any doubt, then you can ask me through my Urban Pro profile. Thanks.